Okay, this is lesson 5.3, which is concerning using angle bisectors of triangles. So angle bisectors are a little bit different than perpendicular bisectors. Perpendicular bisectors are always 90 degrees. An angle bisector simply cuts an angle equally in half. So there's nothing about midpoints involved with angle bisectors. If a point is on the bisector of an angle, then it is equidistant from the two sides of an angle. So it's kind of the same thing as perpendicular bisectors there. The converse says if a point is in the interior of the angle, then it is equidistant from the sides of an angle, then it lies on the bisector of the angle. Use the angle bisector theorem. So it says find the measure of angle GFJ. So we're looking for this guy right here. And so since J is equidistant from both ones, it means this is on the angle bisector. So it means this angle is cut in half, so this side would simply be 42 degrees. Alright, so we have a soccer goalie as shown. Will the goalie have to move further to block a shot towards the right or the left goalpost? And what our answer is if he's equidistant from here to here, and these two angles are equal, it's neither, because he's right in the middle. He's on that angle bisector. Okay? For what value of x does P lie on the bisector? So if P is on the bisector, this has to equal this. So set them up equal to each other. X plus 3 equals 2x minus 1. So subtract my x here, and while I'm at it, I'm going to add 1. So I've got 4 equals x. Ta-da! I'm done. So on these, we'll find x. Well, this is an angle bisector because these two angles are equal. It's cut the angle in half, so this would have to be 15. Okay, this point is equidistant from both sides, so I know that 3x plus 5 has to be equal to 4x minus 6. So subtract 3x. While I'm at it, I'll add 6. So I have 11 equals x. And on this bottom one here, I know that these have got to be equal, so 5x equals 6x minus 5. So subtract 6x. I get negative x equals negative 5, or x equals 5. The concurrency of angle bisectors. The angle bisector of a triangle intersect at a point that is equidistant from the sides of a triangle. So remember, when we talked about the perpendicular bisectors, where they were concurrent, they were equidistant from all of the vertexes. This time, on the concurrency of angle bisectors, that point is equidistant from all of the sides. And it is called your incenter. So far we've covered a circumcenter and an incenter. Okay, so in this diagram, N is the incenter of ABC. Find ND. Okay, I believe this is AN, and I know that this AF is 16, so I can do 20 squared equals 16 squared plus x squared, and we can find what NF is, which would have to be equal to ND. Okay, so I subtract 16 squared. I believe this is 400 minus 256 equals x squared. I'm going to grab my little miniature calculator here. Maybe. I'll put him over here. And do 400 minus, oops, not times. 256, and I get 144. So 144 equals x squared. Well, I just need x. I don't need x squared. So I take the square root of both sides. 12 equals x. So I know that NF is 12, and using my knowledge of end centers, I know it's got to be equidistant from all of the sides, so ND would also have to be 12. And that pretty much concludes this video. Make sure you bring me a question tomorrow, and we'll talk about end centers and angle bisectors.